First, as I tell you every time, read out the problem very carefully. Design a rectangular footing of uniform thickness for an axially loaded column of size 300 mm by 600 mm. Load on column is 1150 kilonewton. Safe bearing capacity of soil is 200 kilonewton per meter square. Use M20 concrete and Fe415 steel. So let's start the solution. WC, the column load, is given, that is 1150 kilonewton. So WF, the silhouette of footing, is equals to 10% of WC, as we know, that is equals to 115 kilonewton. So WC plus WF is equals to 1265 kilonewton, and the safe bearing capacity QU is equals to 200 kilonewton per meter square. For M20 concrete and Fe415 steel, XU max by D is equals to 0.48 as per IS 456 2000, and RU is equals to 2.76. So in last video I have shown you what is RU, how we can calculate RU, and a table which I prepared for different grade of steel and grade of concrete, the values of RU or K. So let's check again the table. So this is the table for M20 grade of concrete and Fe415 steel. The value of RU or K is 2.76, where RU is equals to 0.36 XU max by D within bracket 1 minus 0.42 XU max by D bracket closed FCK. Okay. So RU is 2.76 for M20 grade of concrete and Fe415 steel. Now the area of footing capital A is WC by WF by QU, that is equals to 1265 by 200, that is equals to 6.325 meter square. Now considering length to width ratio of footing same as that of column, that is 2. So y is equals to 2x. So area of footing is equals to x into y is equals to x into 2x, that is equals to 2x square, that is equals to 6.325. So x is equals to root over 6.325 by 2, that is equals to 1.78 meter, say 1.80 meter. So y is equals to 2x, that is equals to 3.6 meter. That means shorter length of footing is 1.8 meter and longer side of footing is 3.60 meter. Now the soil pressure due to column load is 1150 by 3.6 into 1.80, that is equals to 177.47 kilonewton per meter square, and to make it factored just multiply the factor 1.5. So that is equals to 266.21 kilonewton per meter square. Okay, so this is the soil pressure. Now calculation of depth of footing. So for calculating the depth of footing, we know we have to check 3 criterion and have to take the highest value of small d depth. The three criterion are one-way shear criterion, two-way shear criterion or punching shear criterion, and bending moment shear criterion. So first, by one-way shear criterion, the critical section is at D from the face of column. So first check out the diagram of footing. So this is the diagram. Shorter side is 1.80 and longer is 3.60. Okay. So critical section is at D from the face of column, as you see here. Critical section is at D from the face of column. Now shear force in longer direction is 266.21 into 3.6 into within bracket 1.8 minus 0.3 by 2 minus D. So here 266.21 is PU multiplied by 3.6, that is side, longer side of the footing, within bracket 1.8, that is longer side of that is shorter side of footing minus 0.3, that is column by 2 minus D, that is equals to 958.356 into 0.75 minus 958.356 D, that is equals to 718.767 minus 958.356 D. Now shear force in shorter direction is Pu into X in bracket A minus Y minus B by 2 minus D. So that is equals to 266.21 into 1.8 within bracket 3.6 minus 0.6 by 2 minus D, that is equals to 718.767 minus 479.178 D. So this is equation 1. Now shear force resisted by concrete is tau cxt. We can assume here the percentage of steel reinforcement is 0.2. So for 0.2% of steel and M20 grade of concrete, tau c is equal to 0.32. So shear force resisted by concrete is equals to 0.32 by 10 cube into 10 to the power 6 into 1.80 into D, that is equals to 576 D. Now we have to equate equation 1 and equation 2. Before that, just see the picture again. In left side you can see the one-way shear is along longer direction, and in the picture in right side the single shear is light in as along shorter span. Now equation 1 and 2, we will get the value of depth D. So some 718.767 minus 479.178 is equals to 576 D. That is equals to D is equals to 0.681 meter. So as per So as per by value, the one-way shear criterion, as per one-way shear criterion, the value of D is the value of D is 0.681 meter. Now next step is depth of footing by two-way shear criterion. The critical section is at D by 2 distance from the face of column. So you can see here the picture for two-way shear or punching shear. So every side is shear is shown. So you can see the critical section is at D by 2 distance from every side. Now the shear force at critical section due to shaded area is 266.21, that is PU, into 3.6 minus 1.80 minus 0.3 plus D bracket close into within bracket 0.6 plus D bracket close, that is equals to 1725 minus 266.21 within bracket 0.18 plus 0.9D plus D square, that is equals to 1677.08